Physics, vibrations and waves. The problem is the length of a simple pendulum is 0.760 meter. The pendulum bob has a mass of 365 grams and it is released at an angle of 12 degree to the vertical. Find the frequency of the vibration. Number 2, speed when the bob is released at the lowest point. Speed when the bob is at lowest point, and total energy stored in this oscillation mean at the lowest point. We have to find the energy. So how we can do this one? So this is a simple pendulum, and this is its length L, and this is object of mass M, and it is oscillating with a small angle. The angle should be small, otherwise small angle approximation will not work. This is O, this is A, and this is B point. And this is the right angle, and this point is C. First of all, the frequency. Frequency is given by 1 over 2 pi G over L square root. So if you substitute the values, which is equal to 1 over 2 pi, 9.81 and 0.76 meter whole square root, and this will give you 0.57 hertz. So this is frequency, the first answer. Number 2, we have to find the speed at lowest point. So lowest point where h is equal to 0, height is equal to 0. So this is B. So we can find out this is right angle triangle of OAC. So in this one, OC is equal to OA into cos of theta. So OA is L. So this is equal to L into cos of theta. This is OC. Then BC, which is height, is equal to OB, take away OC. OB is equal to L minus L cos theta, and which is equal to L into 1 minus cos of theta, which is h, which is height. The height has two values. H at A, when theta is at 12 degrees, and H at B when theta is equal to 0 degree. When is a 0 degree, then H is equal to L into 1 minus 1, which is equal to 0. So height is equal to 0. This is the lowest point. When H is at 12, so H is equal to L 1 minus, this is some number which is less than 1. So this is some positive number. So it has is not equal to 0. So we will take 2 points. We will use the conservation of energy to find the speed. So energy at A is equal to energy at B point. So top point and bottom point. So energy at A is kinetic energy plus potential energy at A and kinetic energy at B plus potential energy at B. Kinetic energy at A, because it is a turning point, so velocity is equal to 0. So this is equal to 0, and potential energy is mgh, and h is this one. So it's L into 1 minus cos of theta, which is equal to, here at B, H is equal to 0. So potential energy is 0, and mb square. M cancel. So VB is equal to 2GL into 1 minus cos of theta and square root. So theta is equal to 12. If we substitute all these value, 2 into 9.81, L is 0.76 into 1 minus cos of 12 degree. So the answer is equal to 0.5 0.57. So speed is equal to number 3, stored energy. The stored energy at this point is E B, which is equal to half mvb square. This is equal to half into the 360 365 grams into speed, which is 0.57 meters square. So, and this will give you answer 5.95 into 10 raised power minus 2 joule. This is the energy at EB. So this is the answer of the question, and the question is, length of the spring, find frequency, speed at the lowest point, and stored energy at the lowest point. So these are the three answers.